Welcome, ladies and gentlemen, to Lesson 4.2. I can identify proportional and non-proportional relationships. This can be a little tricky, so you want to make sure you're writing down good notes and you have definitions and things like that at hand to be able to identify proportional and non-proportional relationships. About those definitions. If two quantities are proportional, they have a constant ratio. For relationships in which the ratio is not constant, those would be non-proportional. So constant ratio is proportional, not constant is non-proportional. So if you think about, if you're saying someone's super unproportional or whatever, you notice that maybe like, if you think about Hey Arnold, which is a really, really old cartoon, look it up. His head is the shape of a football and it's really big and it's much bigger than the rest of his body. He would be non-proportional. Okay? So that's just kind of a fun way to think about that. But we make sure you understand what a ratio is. So for example, and we'll go into this, but a ratio, remember, is a comparison of two numbers by division. So 4 over 2, that simplifies to 2. 6 over 3 simplifies to 2. So really, these would be proportional or constant ratios because they both simplify to 2. Identify proportional relationships. So, Uptown Pizzeria sells medium pizzas for $7 each, but charges a $3 delivery fee per order. Is the cost of the order proportional to the number of pizzas ordered? So we're looking at cost to pizzas ordered, and is it proportional? Okay? So one thing you want to do here is maybe make a table to show the cost of 1, 2, 3, and 4 pizzas, and to show what the cost is. So we say if I order 1 pizza, and a lot of times these tables are mixed up. Sometimes this is really your X, your input, how many pizzas am I ordering, how many I pay. So I personally like to go this way because it's like, I order 1 pizza. Well, I'd pay $7 for the pizza and a $3 delivery charge. So that's $10. 2 pizzas, that's 7 plus 7, which is 14, and that $3 charge, just that one time, is 17. 3 pizzas is 7 times 3, which is 21, plus that $3 charge for 24. This is where these numbers are coming from. 4 pizzas is 7 times 4, which is 28, plus that $3 charge, which is 31. Just to give you an idea of where those numbers are coming from. So for each number of pizzas, we want to write the relationship of the cost to pizza. So it costs $10 for 1 pizza, so simplified to 10. But it costs $17 for 2 pizzas, so our unit right here would be 8.5 for 1. 24 for 3 pizzas, or 8 for 1. 34 for 4 pizzas, or $7.75 for 1. So what you can gather here is that the ratios that we see here that are simplified, or the unit rates, they are not constant. They do not stay the same. So the cost to pizza is non-proportional because they're not equal, not a constant ratio. So these do not equal each other. Therefore, it is non-proportional. So just simplifying ratios, really important. Okay, so let's look at another example. You can use a recipe shown here to make healthier version of a popular beverage. If the amount of mix used proportional to the amount of sugar used. So if we look, we have 1/2 cup of sugar for every 1 envelope mix. So how we do this is let's make a table. So we're going to find the amount of mix and sugar needed for different numbers of batches, and we make a table. So a 1/2 cup of sugar, we'd need 1 envelope and 2 quarts of water. If we're going to use 1 cup of sugar, we need 2 envelopes and 4 quarts of water. 1.5, so notice we're just going up by 1/2 every time, and going up by 1 every time, and up by 2 every time. So for each number of cups of sugar, here we are, write the relationship of cups and the number of envelope mixes as a ratio in simplest form. So a ratio here, cups compared to mix. So it looks like there's 1/2 1/2 cup of sugar to 1, 1 to 2, 1/2 to 3, 2 to 4. So all of these simplify to be 1/2 or 1/2. 1/2 is half of 1, 1 is half of 2, 1 1/2 is half of 3, 2 is half of 4. So all the ratios between the two quantities simplified to 1/2, just like we said. So the amount of mix used is proportional to the amount of sugar used. That's our final finding. So using that same logic, is the amount of sugar used proportional to the amount of water used? So now we're comparing sugar to water. So if we do that, we are going to say, okay, sugar compared to water. Let's write all those ratios out. So I get 1/2 for every 2 quarts of water. That might kind of work vertically instead. And it was 1 to 4. And 1 1/2 to 6. And then the last one, kind of write a little smaller, was 2 to 8. So what do all these simplify to? 1/2 of 4 is 1/4. You can use calculator. This is already simplified to 1/4. 1 1/2 is 1/4 of 6. And 2 is 1/4 of 8. So since they all simplify to 1/4, the amount of sugar, or the amount of water, and water is proportional because they have a constant ratio. How about one more? Let me zoom out of this one. At the beginning of the school year, Isabel had $120 in the bank. Each week, she deposits $20. Is her account balance proportional to the amount of weeks since she started school? So we're looking for, is her account balance proportional to the number of weeks since she started school? So I'm going to make a table comparing what her balance is to the number of weeks in school. What I know she started with, she had $120 in the bank when she started, so that's 0 weeks of school, say. So after 1 week of school, if she put $20 more in, that's 120 plus 20 for 140. The second week, she put another 20 in, that's 160. So notice we're going up by 1 and up by 20 every time. Third week, she'd have 180. The fourth week, she'd have 200, and so on and so forth. So is it proportional? Well, let's see. 140 over 1 is 140. So I'm simplifying these fractions, these ratios, down right below. 160 over 2 is 80. 180 over 3 is 60. And 200 over 4 is 50. So that means, since these ratios are not equal or not constant, that her account balance, and I'm not writing in full sentences because the stylist, is not proportional or non-proportional to the number of weeks in school, since these are not equal. So what you'll notice is that simplifying fractions, ratios, is super important. So make sure that you are working on your dividing and that you're showing your work and that you're doing your best. Make sure you come with notes and asking questions. See you soon.